Okay, this is pre-calculus. What's my sine cosine? Last video, and these last two, 10 and 11, are for the graphing portion is have horizontal shifts in that, and these last two are pretty interesting. So the first thing I want you to do is I see that there's a horizontal shift. There's no vertical shift because there's no, the midline looks like y equals 0 because I'm not adding or subtracting on the outside. So we're going to factor out the 4 on both, the 4 pi out of both of these. I meant to say 4 pi. And so I'm going to factor the 4 pi out. And when I do, I get t plus. And if I divide 6 pi by 4 pi, we get 3 over 2. So watch, 4 pi t, and that would be 12 pi over 2 or 6 pi. So you're like, okay, good. This is my phase shift, which is going to the left, 6 pi. The horizontal shift is after I factor it, so I have -3/2. Remember, we use this to graph. However, I want to talk about the phase shift on this one because it's quite interesting because it kind of gives you a head up when you're going to graph. That if I took the phase shift, okay, I'm going to do 6 pi, divided by the 2 pi, because that's what a phase shift is you take what that comes out to be in your equation, divide it. When I do, I get a 3. This means it went 3 entire cycles, and because it's positive, to the left. Okay, that's kind of interesting. This entire graph has 3 entire cycles to the left. So that kind of gives you a head up when I go to sketch the graph. You're like, I've got a lot coming over here on the left. My graph is going to be over here on the right somewhere. Okay, let's go do what we always do. Let's do our amplitude. Our amplitude is 3. My frequency now is 4 pi, which it was before anyway. The period is 2 pi over 4 pi or 1/2. Okay, so that's a period. So a whole entire look at this graph is 1/2. So I have to figure out how am I going to graph this. So I take the 1/2, divide it by my 4 quadrants, and I get 1/8. So I'm going to do this table like I'm not shifting it, like we've been. So here's my table, X and Y. This is a sine curve, so I know it's going to start at midline, but here's 0, 1/8, 2/8, which is 1/4, 3/8, and 4/8, which is 1/2. Because it's sine, it starts at midline. It's not negative anymore. It's going to go up, and the amplitude's 3, so it's going to go up to 3, back down to the midline, down to -3, back up to the midline. So this should be kind of good. But I'm counting by 1/8. My whole entire graph is 1/2, and the phase shift kind of gave us a heads up. I've got to do 3 graphs to the left. So I actually made my graph, let me see now, 1, 2, 3, 4, 5, 6, 7 parts here. So I'm going to do 1, 2, 3, 4, 5, 6, 7. So right here is my y-axis. All right, really, that's what I did. And then I know it's smack dab in the middle, so that's okay. So you're like, oh, this one is really different. So the graph I'm going to graph is going to be way over here to the right. Then we have to shift it to the left, and you'll see what I mean by that. So I'm going to count by 1/8. Okay, so I'm going to actually count each one. So this is 1/8, this is 2/8 or 1/4, 3/8, 4/8 or 1/2. So I actually used every single one of these. All right, and I'm going to graph 3. I'm going to go 1, 2, 3. So I'm going up 1, -1, -2, -3. I'm going actually every 2 blocks, I should say, down to -3. So if I were to graph this original one, and actually I'm going to do this one in green, or else you're not going to see what I'm doing, is it's 0, 0. At 1/8, I go up to 3. At 1/4, I'm back to 0. At 3/8, which is in between these, so -3, and then back up to half. So this graph looks like this. All right. Now, see the horizontal shift? I have to go -3/2. Well, that's 3 of these. All right. So I actually went backwards all the way to here. So I mean, you would have to count backwards, but let's do that. So I've got a 0. I'm going to do a -1/2 here, a -1. Let's try that again. -1/4, -1/2. Okay, then I've got to go again. So that's going to be, right, -3/4, -1. So there's a half, there's -1, and then I'm going to do -1/2, -3/2. So I went all the way backwards. So basically, the graph that I end up here is my actual answer. So I'm gonna do this one in red. So see how it goes? It goes here, up to 3 in the middle, back down to 0, back down to -3, which is here, which is there. There is my actual graph. That's what I want to do this. So this is the one over here that if I didn't shift it, but it got shifted to the left, -3/2, that's 3 entire graphs. In between here, I'm going to put the other ones that what this would do. So again, we're going to come up here. I'm going to use it in yellows to show you. There's one of them. So it keeps going. The graph keeps going. Then we're going to come up here. And there we go. So the graph kind of keeps going, but the one we're looking at for the answer is what's in red. So that's an interesting graph. And the phase shift kind of gave us a heads up. The last graph we're doing here is number 11, and I've got 10 sine 0.1 plus pi. So 0.1 kind of freaks everybody out. So we're going to kind of write this as 1/10 t, okay, plus pi. So I'm going to factor out the 1/10 because it makes it a little bit nicer to look at. So if I take out 1/10, which is what 0.1 is, so it's t plus, now this is a 1 in front of that. If I divide that by 1/10, 1 divided by 1/10 is like multiplying by 10, so that's going to be 10 pi, okay? All right, so let's kind of do this right now. Let's do our phase shift right here would be just a negative pi because it's going to go to the left, which is interesting, but what we're looking for is this. This horizontal shift is negative 10 pi. That's interesting, and this is what we use to graph with, okay? Our amplitude's 10, so we got a lot of 10s going on. This gets stretched 10. My frequency is 1/10, another 10. My period is going to be 2 pi over my frequency of 1/10. So my period is actually 20 pi. That's pretty big. And my midline, because there's nothing added or subtracted on the outside, is y equals 0. I think I got that all in there. Let's take our period of 20 pi, divide it by our 4 quadrants like we weren't going to shift it, I would get 5 pi. So I'm going to set up my table here, x, y, start at 0, 5 pi, 10 pi, 15 pi, and 20 pi. So I got to where I needed to be. And because this is a sine curve, remember it starts at midline, which is 0, and it's going to go up to this highest point, which is going to be 10, come back down to my midline, go down to -10, and come back up to my midline. So there's our points. So again, setting up the graph, what should we do? I have to go to the left. So I actually this one's like my smallest one. So I'm going to use, let me see now, 4 points here. I got 1, 2, 3, 4. So I'm going to draw this because I'm shifting to the left. And then I'm smack dab in the middle. Okay. And I'm going to start counting by 5 pi. So I kind of skipped this and did every 2. So this is 0, 5 pi, 10 pi, 15 pi, 20 pi. And I knew I had to shift to the left -10 pi. So here's -5 pi, here's -10 pi. So this one is the squishiest of all of them. I'll put 15 pi here. So I'm going to, and I have to go up to 10. So I actually did every 4. 1, 2, 3, 4. Here's 5 pi. Excuse me, 5, not 5 pi. 5. And then I did 10. 1, 2, 3, 4. You don't have to go up that much, but I did. Okay, so now I'm going to use the yellow to graph the graph that is not really our graph. So I got 0, 0. 5 pi is 10, back to 0, down to -10, back up to 0. So here's our graph before the shift. Now I'm going to shift it to the left, and I'm just going to copy those points. Okay. So it kind of overlaps a little bit. What's in red is the graph. So it's not so pretty, but I hope that you can see what I did here, and I hope that helped.